Hi friends, today we are going to discuss about, that is, we are just going to continue the chapter uh, light reflection and refraction that we were discussing. Now we will start it with beginning. First of all, we should know what is light. Friends, we know that there are different types of light energy. So light is a kind of energy. First, in the first sentence, it is itself written that it is a form of energy. So we know that there in our surrounding there are lots of energies like uh, light energy, electrical energy, sound energy, and every energy has its own purpose and its own use. So what is in light energy? So the main objective of light energy is to enable us to see this beautiful world. Without light we can't able to see the surrounding, because light enable us to see the things as the and the main property for this is the reflection. Our when the light falls on when the light falls on our eyes, then it get reflected to the object and it bounce back the light and we are able to see. Now light always travel in a straight line. It means that the path of the light, usually a light is represented by a ray. This is a ray. In this way a light is, when you do the ray diagram of the light, in this way the light ray is represented. This is the way of light ray representation, and it always travel in a straight line. Night other things that move in a curvilinear or periodic, any kind of movement they show, but in case of light it always travel in a straight line. The next comes light makes shadow. Without light shadow is not possible. Yes, it's correct. The most wonderful example for this is your lunar eclipse, solar eclipse that we see, and that the normal you see when the sun is in your head. Okay, if this is the sun and you are somewhat standing here, if you are standing here, then it will cast a shadow in back of you, because you are, in this way the light ray is coming and you are making a obstacle for it. You are working as a obstacle for the light ray to go further. So when something blocks the light ray, it casts a shadow, and the one of the example is lunar eclipse, solar eclipse. Then the last point is light speed. So after so many calculations by our physicists, they finally got a perfect value for the light speed, is that the light always travel into 3 into 10 to the power 8 meter per second. This is the scientific notation, the speed of the light, and we always compare anything with the speed of light. Now the important topic, that is the reflection. What is reflection? Reflection is nothing, friends. It is a bouncing back of light. It is nothing but a bouncing back of light. For example, if this is your wall, if this is your wall and this was the ball, you hit it towards the wall, the ball will go like this, hit the wall, after hitting it will come back. So if I draw a normal perpendicular bisector of this wall, then there will be two angles. One is angle that is going towards the, making an angle while going towards the wall, and after coming back from the wall, that is after bouncing back, is again making an angle. So these two angles are always equal. This is called reflection, and this is nothing but the law of reflection also. So let's discuss what is reflection. Is coming back of light ray to the same medium when they fall on a surface. So if the surface with the same medium, when they come back, as I have shown here, it is said to be light ray. So reflection has two laws. One is angle of incident is equals to angle of reflection. Yes, as I have shown here, this is the incident, means the light that is falling towards the surface, this light is incident, and the light that get bounced back is called reflected, and the angle it is making in between the normal, this is the normal, is always equal. You can see here, see, this is the incident light and this is a surface, this is a surface. So after striking it, and this is a normal, that is a perpendicular drawn, this is a normal, and after reflection, this is called the reflected ray, the angle represented between the normal and the incident ray, that is represented by angle of incident I, and the angle between normal and reflected ray, that is represented by small r, it is always equal. This is the first law. And the second law says that the incident ray, the normal and the reflected all lie in the same plane. Yes, my dear friends, see, the surface is all same plane, means the surface will be same. So you can see that the normal, the reflected, and your reflected, your incident, the normal, all are lying in the same surface. So this is the second law. Now let us discuss about types of images. So in case of type of images, there are two types of image. One is real image and one is virtual image. So what is real image? Real image are always inverted, and the virtual image are always erect. Means inverted means upside down, and erect means always straight. A real image is formed by convex lens and concave mirror. This is quite important and it is usually asked in 1 marks questions. The real image is formed by what kind of lens and mirror? So it is convex lens that forms the real image and concave mirror. But in case of virtual image, a plane mirror and a convex mirror both forms a virtual image, and a concave lens forms a virtual image. Real image are formed on screen, but virtual image cannot be formed on screen. One of the best example is that the cinema hall theater. Yeah, the best example is the cinema that is projected on the screen is a real image, and whatever you look in the mirror is the virtual image, because the image is formed behind the mirror, not on the screen. And this is formed due to the actual interaction of light rays, and this is are formed due to the imaginary interaction. This is an actual interaction and there is a imaginary. It is just means thought that such kind of interaction has been occurred. Now let's discuss each mirror one by one. First is plane mirror. So what is plane mirror? So plane mirror is usually that kind of mirror that we use at our home. Object and image are at equal distance from the plane mirror. Means what it wants to say is that if this is the mirror and the distance where the image is formed and the distance where the object is standing will be always equal. If the object is real, then the image will be virtual and vice versa. So in the plane mirror a virtual image is formed and the size of the image will be same. Means if you are 160 centimeter, then in the mirror, plane mirror, it will show 160, not small or not large. And one of the most important property of plane mirror is the lateral inversion. So friends, what is the meaning of lateral inversion is that we usually, when you see in your mirror, you get confused that your left appears right and your right appears left. So this is called the lateral inversion. So to get rid of this, we usually have seen that in the ambulance is written from right to left, but we usually write anything from left to right, but in the ambulance it is written right to left, so that when you look in the mirror it will clearly observe you in a correct format. Okay, then you will get the idea that the ambulance is coming. This because of the lateral inversion. So the right side of the object appears left side and the image. Okay, so this is the plane mirror. For example, looking glass, periscope, kaleidoscope, these all are examples of plane mirror. Now let us talk about the spherical mirror. Spherical mirror. So spherical mirrors usually is important part is this is the reflecting surface. Up to this is its reflecting surface, but when we considered it as a whole sphere, then there are so many parts which are quite important for the image formation in spherical mirror or lens. So this point you can see, if this is a whole a circle, oh sorry, sphere, then the central part is called, center of curvature, and a line like a diameter that is passing through the center is called principal axis. you can see this is called principal axis. This is the principal axis. See, this is the principal axis, the line, and this is your pole, and the line that is intersecting the mirror, this point, this is called pole, and the distance between C and P, that is the center of curvature, and P with this distance is called radius of curvature. Radius of curvature. Radius of curvature. And if I draw a line, the half portion, the middle portion of this, which is represented by F, capital F, this is called focus. This is called focus. This is called focus. So you can see here, this is your focus, this is your principal center of curvature, this is pole, and the half in the middle portion is the focus. And the distance between focus and the pole, okay, this is represented by small f, and this is called focal length. The distance between P and F is called focal length. So you can see this represented by small f, focal length. So this was all about the spherical mirror. So here one by one things has been highlighted: the radius of curvature, the distance between pole and the center of curvature. Center of curvature means the center of that imaginary sphere. Okay, as I already told, pole, it is the midpoint of reflecting surface, and principal axis, the line joining the pole and the center of curvature, or usually you can say the line passing through the center of curvature. Focus is the principal axis where all the parallel light rays actually meets or appears to meets after reflection. This will be this topic will be more cleared when you study the ray diagram. Okay, what it means to say is that from any reflecting surface, after reflection, if this is the light ray going and this is the focus parallelly going, then after reflection it will go like this, or in case of concave or convex it will go like this if the focus is there. This is what it wants to say. Then aperture. Aperture here is not shown, I will show you. If this is M and this is N, so its distance, this is called aperture. Okay, now focal length, as I already told you, the distance between the pole and the focus, and this is the one of the most important formula for the numerical solving, that focal length is half of center of curvature. Okay, thank you, that's all for today.